Fred? Oh, you're on mute. And I think I'm on mute too. No, you're on mute.
Okay, so I'm
Now I
not
can hear
on
you.
mute now. Okay.
Yes, now I can
And
hear
we've
you.
got some people joining us.
I'll bring up the note well and be ready to share it.
Hello, Ron.
Hello, how are you, Jen?
Good, good. How you doing?
Okay, let's go back to the screen and see what everybody looks like. You still look the same after lockdown.
Thank you. I'll take it as a compliment.
We all grew beards, gave ourselves haircuts.
Yes, sir. So what do I need to do when I will be presenting? Do I need to share my screen?
Well, you'll need to share your slides. If that's your screen, so be it.
Okay. I'm sharing my screen. Yeah.
Okay, I've got the note well ready to share.
Okay.
Go ahead
So I
and
don't
put
need
it
to
up
do
if you would.
What's that?
Go ahead and put it up if you would.
Okay.
I don't see Ben. Has Ben joined?
I don't think yet.
Oh, yeah. Why I'm showing up as Energy Research Group?
Yeah, once WebEx believes that it knows who you are, it's almost impossible to make it forget.
There.
So what can I do with all my multiple personalities?
Sybil! It's a Sybil attack.
There, can you see the note well?
Yeah.
I can see the note well.
Okay.
Fred, I'm 冲锋.
Hi, Jordy.
Hello.
I'm always amazed to see what people look like during lockdown. You know, who's given themselves a haircut, who's grown a beard.
Well, California emerged from lockdown and is busily sliding back into it. So.
Yeah.
But actually it's the same if you see the people face to face every 3 or 4 months, right?
Yeah.
IETF to IETF.
But now it's been 6 months.
Yeah, exactly. But I mean that normally you have the same thing. Has the guy cut his hair or changed his look or whatever every 4 months?
I'm going to take this down so I can see what people look like.
Okay, Jen.
Yeah.
I don't see Ben yet. I was expecting him to be the first speaker. You should probably have your slides ready in case he doesn't materialize.
Okay. I'm almost always ready, actually.
Let's see here. Ron, is there a way to record this?
Yes, there is. Hang on. I will figure it
Yeah.
out.
Actually,
It said recording in progress, no?
yeah. So, okay, I guess we're recording.
We don't need a JabberScribe since everybody is remote.
mhm.
And, do we have a minute taker?
You can record the session.
What's that?
You can record the session. Better minutes than recording the session.
Well, we do that all the time anyway.
Okay.
Yeah.
Yeah, the problem with using a recording as minutes is you can't scan and say, oh, the person said this. You have to go listen to the whole recording.
Yeah.
Yeah.
Yeah, Warren says we still need a minute taker.
Yeah.
Okay. I'm looking for a volunteer. We have 30 people on the call. Who's willing to take minutes? Don't all speak at once.
Let me start looking for volunteers.
Okay.
Noah, would you be willing, Noah?
Noah, you're on mute. Ah, Ben's here.
My network here in Dar es Salaam, Tanzania is a bit slow.
So do you need to turn off your video? Is that what you're getting at?
My video is actually turned off. Oh, can you guys hear me?
Yes, yes. Yes, I can hear you, Noah. Would you be willing to take minutes? Okay, he might have a connectivity problem. Do we have anybody else who'd be willing to take minutes? Scott, would you be willing?
This is Warren. I can do it.
Okay, thank you. It is now 4 minutes after the top of the hour. Let's go ahead and get started. And Ben, can you share your slides from there?
Let me stop sharing. By the way, this isn't well, note it well.
Quick question. Do we have a WebEx link? That's not a WebEx Etherpad.
Sure. Do you want me to email it to you or what?
Or stick it in the chat. Or I can just take notes on my own machine, just if it's an Etherpad, people can, fight and make them better.
Okay. Well,
Hello? Sorry, guys. My question is a bit unstable. Somebody else perhaps volunteer, if that is okay.
Sure.
Could you volunteer perhaps? Sorry. So, oh,
Can everybody hear me?
I can hear
Yes.
you. Okay. Okay, so we see your slides, Ben. Please feel free to talk to them.
You can let me know if we can start now.
You can start.
All right, thank you very much. Good morning, good afternoon, good evening to everybody. So this is my presentation. My name is Ben, and I'm with the Research and Education Network for Uganda. So I want to present our case scenario for IPv6 deployment. I will do a little bit of introduction about RENU, which is a Research and Education Network for Uganda. RENU is the NREN that operates in Uganda, and we are basically mandated to give ICT support and services to such institutions, academic institutions, tertiary institutions, and some government parastatals. So it started way back in 2006, but the network kicked off in 2014. And by then we only had 1 point of presence, that was in Kampala. And we started with 1 member institution. So 1 point of presence, 1 member institution. But currently the network spans across the entire country with 6 points of presence. Then we have also 6 different aggregation points where different members connect. So with all this, we have about over 200 members now connected on the research network. So amongst these 200 members, we have about 8 members speaking V6 or being able to use V6 right now. And some challenges that I'm going to be sharing with you have led us to have some of these members not connecting, but we are working on it. So I'll just give you an overview of what our network looks like. In simple terms, we have a purely fiber optic network that's from the backbone and also the access technology. We don't have microwave, but microwave is in the future. And it's something we are looking at. There are areas which are hard to reach with fiber. So microwave. At the access level, basically most of the technologies we're using, we have VRRP, which is basically helping us to do with switching between links or access links for the institution on the backbone. So every member basically has 2 links. So that means their access is backed up. They connect to different points of presence. And we VRP for being able to switch. So we use also BFD with static routes, which helps us to detect basically failures on different access links. And then obviously we have some members who are able to speak BGP with the NREN. So we also have BGP at access. In the backbone, like I said, we have 6 points of presence across the country. And basically we are running ISIS within the entire backbone and BGP and also RSVP protocol signaling. So basically ISIS was one of the advantages that we had when we started to roll out IPv6, because moment, we didn't need to create another instance in case like we're using OSPF or something. We basically just had to define depending on the INET families. And that was a big advantage for us when we're starting out IPv6. So basically, if you see from my diagram on this side, the network is purely a dual stack network. So we have each member is a representation of a given member. We give IPv4 and IPv6 in their LAN. They connect to us over IPv4 and IPv6, and also the backbone is purely dual stack. We have two forms of server installation. We have the Reno Cloud, which is an open stack. And you can see in my presentation, this is currently only version IPv4. I'm going to speak about this later on in my presentation. The other servers we have, which are running on the Ganeti software for able to support dual stack. So these are dual stacks. And this is basically the highlight of how our network is laid out. All right, so with our dual stack technology that we're using, we have had a couple of advantages that have helped us basically to execute this and to reach where we have reached. So I would like to start by talking about the boosting points. Basically, the management has been able to train engineers. That means the NREN engineers and also the institutional engineers. This has helped us to be able to support it. We understand. So it's one of the things that has helped us to be able to roll out to the point we are. And then also the other advantage is that we have IPv4 within our backbone. So we are not doing nothing anywhere in the backbone. Basically, the backbone is running on version 4 public IPs. So this was a big advantage to us, meaning that we are not going to have to do a lot of maybe NAT, V4 to V6 NATing and all the other stuff. So it helped us also to move smoothly, and also the ISIS instance, I already explained this. Then within the research and education network, we have what we call the direct engineering assistance program. So this is where the NREN sends a cohort engineering to a given institution. So what we do there is we try to make the network of a given institution better by cleaning out all the bottlenecks, deploying services that we see benefit the institution. That means we have an advantage to be able to deploy IPv6 during the direct engineering assistance. And this is how we have been rolling out IPv6 to different institutions. We train them and we are able to give them all they need to support it. And we hand it over to them for taking over after that. And also the other advantage we've had is that we have had an equipment donation support from the NSRC, because among the such challenges that we've been facing, many member institutions don't have equipment that is capable of supporting IPv6, and they don't have the budget for it. So this has helped us to address. All right, so I'll shift to the side of the challenges that mainly we are facing right now. When we rolled out IPv6, and then the member institutions were joining the network and joining, we faced a challenge with incapable nodes, because at the moment we were running Juniper MX5s within our backbone, and these could not support the full routing table for V4 and also for V6. So we had to rethink, and we solved this by sending the default route to the smaller routers, and then we are able to acquire bigger Juniper MX480s, which are now acting as routers within the backbone. So we have two Juniper MX480s, which are strong enough to support both routing tables, and then within the smaller backbone routers, we send the default route. So this is what I call the cost of dual stack. You have to be able to have nodes which can support both routing table if you're going to use a full routing table all the way to the access level. Then the other challenge that we faced during our deployment was to be able to have a unified bandwidth policy for both IPv4 and IPv6 for a given particular member institution. So when we did roll out IPv6, we found out that actually a given member institution was able to do twice the capacity they subscribe for. So we solved this by doing per policy, per protocol policy, whereby we have filter applied to the version 4 and also the version 6 for that given particular institution bandwidth, and then this works fine. So whether they are V4, whether they are coming in V6, they will still use the same given capacity they subscribe for. They will not be able to do twice that. And then also the legacy nodes that are within the institutions which do not support IPv6. So we face this a lot when we are rolling out IPv6 in different institutions. So you find the core equipment they have at the back of their network, it cannot support IPv6. They need a license to actually be able to support V6. So and they cannot afford the license. So this has also been a big hindrance to many member institutions. And then the other I talked about is the adoption within OpenStack. That is now for our cloud instances, because we provide the cloud service to member institutions whereby they are able to come and they get different VMs, all they need. We are hosting websites within the same cloud service instances. So these need to be on both V4 and V6 for better support. But with the current version of OpenStack that we are running, which is version 11, it cannot support IPv6. And we are looking at having to upgrade it in the near future so that we are able to have a cloud also dual stack. Then the last challenge that we are facing at the moment is most of the CDNs at the internet exchange point actually only giving us IPv4. So you find that our member institutions who are on V6 do not have the same experience as the people who are on V4, because the CDNs at the exchange have not yet turned on the IPv6. We are only getting V4 traffic mostly from the exchange. So those are mainly the challenges we are facing right now, and some we've been facing that we've been able to work around in different ways. So I will talk about how we've been trying to see that we pick up member institutions to actually start rolling out V6 within their network, because we have IPv4, which they may feel this is enough, but we've done a lot of intensive training for the engineers to actually give them the skills whereby they are ready to support the network even without the engineering engineers. They can really stand alone with it. So first thing is we did a lot of training for member institutions. So when the engineers and the institutions are able to appreciate IPv6, its importance and why it's here, then we go ahead and do the deployment with them. So we help them through what we call the direct engineering assistance, or the DEA. So we help them with IP planning, we help them with setting up DNS and DHCP and all the other aspects so that they're able to actually support the network. Then also through different partners like NSRC, we get some equipment which is capable of doing better routing for V6 and V4. So we also do the donation to given members. And this, of course, is not enough to cover the growing number of institutions, but we keep on pushing and pushing. So we do donate, pass on this donation received from NSRC to the different institutions, and they are able to also join the V6 network easily. Yeah, so when we look at more work that we are planning on doing, besides making sure that our OpenStack is able to support V6, which is going to be upgrading to a better version, which can support V6. We also want to work at gathering measurements so that we can have proof of success. this is still going on with our and different data and statistics are being gathered, whereby at the end of the day we can be able to actually produce statistics which can show our progress and proof of our progress. Thank you. So at this moment, I'll come in comments. Thank you.
Okay, thank you, Ben. So could you go back to the slide of the issues that you see, the challenges that you're experiencing? Are there any of these that we can address in the IETF? Doesn't really look like it. Now, OpenStack has had IPv6 capability since the Neutron release, which I think was 2015 or thereabouts. Are you finding other users that also are using IPv6 in OpenStack? Ben?
Not sure of other users, but I know that newer versions of OpenStack actually can support both IPv4 and IPv6. It's a hindrance that we're using at the moment, a lower version. That's why we are still reading around deploying or migrating our cloud to a newer version of OpenStack, which can actually support both protocols.
Okay. Well, okay, does anybody, I would love to have the feature that we have in Zoom, which allows people to raise hands. I don't see that in WebEx. So if you, I'm sorry? Okay, someone is speaking in Chinese. I don't understand. So if you want to do the equivalent of raising your hand, please drop a note in the chat room.
And would everyone who's not speaking please go on mute?
The noise seems to be coming from Olivia. I don't know if the host can mute them.
Okay, I muted Olivia. Well, okay. I don't see any questions coming up. So the equivalent of the chat room. So, or of the raise hand feature. So let's move ahead to Jen. So that means, Ben, that you need to stop sharing.
Okay. Am I supposed to share content? Oh, beautiful. Okay. Okay, now, can you see the slides?
Yes, you broke the treadmills.
I did. No spoilers yet. So, hello. I'm going to talk about unicorns, about something which many people consider being impossible nowadays. I'm going to tell you a story about converting at least part of an enterprise network into IPv6 only mode. Obviously, some people might ask, why would any sane person ever do that? Well, I had plenty of reasons. First of all, we actually managed to run out of private address space. Yes, it's possible. Secondly, we're getting an increasing number of requests from various developer teams for IPv6 only environments because they need to use it for testing, for dog fooding, to making sure their products work in V6 only mode. And last but not least, I realized that actually operating dual stack is hard. It's not news actually, right? So, and I'm a big fan of not multiplying entities without necessity. And obviously running two protocols on every single host is actually not a necessity anymore. So what we actually did to prove that it's possible and the sky is not going to fall, we looked at the low-hanging fruit. We looked at our guest network. And our guest network consists of two parts. First, it's a guest wireless, the one our visitors using and actually all non-corporate devices are connected to. And it's actually quite a big one. More than half of all wireless devices connected to our enterprise network is connected to guest one. And we also have a wired network, which is used mostly as a fallback network for all unauthorized devices connected to wired. And as a result, that network was actually using a lot of IPv4 address space because we need to provision for scenario when no devices could authorize. But normally it's heavily underutilized in terms of using address space. So we decided to use this as a proof of concept. Design elements. As far as I know, the only way to actually turn off IPv4 on an end host is to use NAT64 with a combination of DNS64 mostly. Our guest network already was using Google Public DNS as DNS server, so we just changed it to Google Public DNS64. And we configured NAT64 on the same edge devices which are used for NAT44. It will simplify the traffic flow, so all traffic taking the same path, doesn't matter what protocol it is. And we are not using any form of DHCP, so all configurations happened via Slack. So DNS servers were provided via RDNS. Simple, easy. So first, indeed, we had to do a pilot. And the goal of the pilot was to answer a number of questions. First of all, I need to know what percentage of users actually need IPv4. Would it be 50%, 25%, 5%? And as a result, how much of address space I can reclaim? Because we were really need to reclaim some IPv4 address space to reuse it. Also, you don't know what you don't know, so it would be very interesting to find out what kind of applications would fail and would it actually affect the business processes. And another point which was raised, and it was actually a big concern for some people, what would be impact on the support line? Would our IT support infrastructure just melt because it will be an avalanche of angry customers, or probably nobody would notice? So we selected a number of pilot sites. Oh, well, I guess every network would have their own criteria. And for me, the main criteria was the presence of network operations team, because troubleshooting would be much easier when you have people on site. And then we looked at sites where we have a large number of devices to ensure we have enough variety of end hosts and applications. And I kind of cheated and I looked at sites where customers already requested IPv6 only network, which would mean I already have early adopters willing to try, willing to use it and report issues. And I also made them happy by giving them what they asked for. So, as I said, we had wired and wireless network, and we actually did pilot slightly differently. For wired, it was easy. We just changed our DNSS, turn off IPv4, but the thing is, we had no idea what people plugged there. because it's by definition it's the network for third-party unauthorized devices. So we did not want to break things for users. So what we did, we gave them a portal where the user could go and request IPv4 to be enabled back. So basically the switch port was moved to a dedicated VLAN for this. And users were not forced, but were encouraged to open a ticket and report why they did that, because I wanted to enumerate all issues and find out what kind of use cases we have for enabling IPv4 for guests. Well, obviously I did break something right away, and it was actually the biggest issue of the whole project. Seriously, high priority tickets, people very unhappy because I broke those devices. Apparently, a lot of people want to watch YouTube and Netflix while exercising, and turning off IPv4 took away that capability. I didn't even know those devices need to be connected to network, but anyway. Well, it was easy workaround. We enabled IPv4 back for them, and we're actually talking to a vendor to see if they could fix this, because I looked inside at the kind of very old Android, so I guess eventually they should just upgrade the version and it will get IPv6, but we'll see. So, what did we find after the WiredGuest pilot? First of all, we found out that most of our sites do not need more than a few IPv4 enabled guest ports, fortunately, except for sites when we have gym equipment, because yeah, in this case, we need enough IPv4 address space for every exercise machine, which is connected to the wired network. As a result, we reclaimed a lot of IPv4 address space, basically all of it, most of it, because we ended up giving like /27 per site, which is nothing, peanuts, comparing to what we used to have. And we found two primary use cases for enabling IPv4. First of all, it's a kind of embedded system special devices like IET type stuff, which yeah, obviously is a kind of behind in terms of IPv4 support. But another very common use case is a scenario when user connecting a router, a CPE to the wireless port. So what happened in dual stack segment, right? Users have a cheap CPE, plug it to the wired guest segment, and voila, the user has its own private testing network, because the CPE just getting private IPv4 address and using NAT44 to that address, and for us it's just a normal host connected to a network. Now I came and took away IPv4 from that segment. What obviously happened? That CPE cannot get IPv4 address, so it could not do any translations for IPv4 traffic, because actually it could have done it if it enabled 464X, right, on that interface. Unfortunately, I was unpleasantly surprised that a lot of CPEs, at least ones our users have, do not enable 464X or don't even support it. So one of our primary use cases, and this is actually a great success story, was that we have a kitchen equipment, kind of smart scale from LinPass, and those devices actually have a small router inside, and that's why they broke, right? So that router, even after they added support of IPv6, like getting IPv6 address and getting DNS via RDNSS, they still needed to do something with that private VLAN behind the router. So this is how layer violations look in nowadays. I had to use a screwdriver to enable IPv6 on that device, which yeah, I still think it's a layer violation. So, and actually they fixed it for us. So now our kitchen equipment is capable of doing 464X on their upstream interface, and they works fine on IPv6 only network, at least the testing equipment, which I have on my desk. So this actually proves that if you talk to your vendors, you might actually get things fixed. So question, actually, I looked at the router requirements and I found it a bit confusing. If you look at the router requirement RFC, it doesn't even mention 464X as a transition technology. if you look in IPv4 as a service router requirements RFC, it does mention 464X LAT, but I found it not easy to find because when you start looking for router requirements, you first come in after 7084. So I'm just curious, are we doing like good job on making clear that routers should support 464X LAT when the uplink interface doesn't have IPv4? Because I think it should be reasonably easy for a router to detect. It could do 7050 to find a prefix, or it could use array NATX4 option to discover the network is V6 only. And I think the user's life would be much more easier if routers just automatically enabled 464X LAT on upstream. So Wi-Fi, the biggest network, as I said. So we did not want to upset users, so we did it in baby steps. First, we did opt-in phase for about a year. We created a dedicated additional SSID, and we sent emails to users asking them to join that network, try it, and tell us what does not work. And then, after we became reasonably confident that we can do that, we actually made our primary guest SSID V6 only, but again, to provide users with some form of fallback mechanism, we created a dedicated fallback SSID. In both cases, again, we asked users to report why they fallen back to dual stack SSID, what does not work. So, pilot results. During phase 1, we found that, yeah, it's hard to ask users to do something, right? Most of them do not read emails, so ignore them, or they just do not care. So we actually got about 10% of users moving to a new SSID onto our request. And because we actually asked them to report bugs, we tried to motivate them. So it was a kind of lottery system. Every time you report a bug, you're entering for a kind of raffle. And as a result, like $200 were donated to a charity of the winner's choice. And as a result of this, we got about 15 bugs reported, and 3 of them were immediately, like in the matter of months, fixed, which demonstrated that we probably should be reasonably good to go and make IPv6 only as a primary mode for guest network. So, phase 2 result, what happened when we made IPv6 only guest network primary. Surprisingly, less than 5% of our users fall back to dual stack 1. So probably because most of those devices are actually mobile phones, right? They do work quite well on IPv6 only. So how many of them? It's an absolute number. So we got about 25K peak device count on V6 only network and simultaneously. Individual devices in different devices. It was pre-COVID, obviously, yeah, because now we have less people in the offices. So actually quite a lot, I would say. Again, not so many bugs reported. And because now more users notice that something might not work, we got 4 other applications fixed. So we're making it better and better. So probably when you start enabling IPv6 only for your users, at least some applications will be already fixed for you. So remember those questions we wanted to answer as a pilot? So the most important question, what percentage of our users need IPv4? As I said, about 5% of them explicitly fallen back. So they were on V6 only SSID, but for some reason they fell back. Actually, we had another 10%, which were constantly sitting on the special 2.4 guest SSID, which were sharing the same network segment with the guest one. And we intentionally did not touch 2.4 SSID because we assumed that if device is old enough for not being able to use 5 gigahertz, it probably would not work very well on V6 only. So in total, we have 15% of users staying on dual stack, but it's really hard to find out where all those 10% of users on 2.4 are coming from, because I suspect that some of them just randomly connect to some SSID. So maybe some of those devices actually could be on V6 only. And for virus,
Jen, let me interrupt you a moment.
yeah.
We have a question in the chat room. Are the numbers you're giving out for Wi-Fi only, or are they wired as well?
So this is Wi-Fi. This is Wi-Fi. Because for wired, we do not have many devices there normally. We would have a lot of them if our radius fails and we would not have .1x working. But we do know that most of our workstations would work on V6 only, at least in the guest network, at least in the emergency mode while we're fixing radius, right? For wired, we had, I would say, off top of my head, we're talking maybe about 1,000 devices in total migrating to V6 only. But most of users are obviously sitting on wireless, yeah. So 25K simultaneous devices at peak time on Wi-Fi V6 only. This is what we saw. Does it answer the question?
He says yes.
Okay, thanks. So for wired, again, we have very few devices count. Yeah, as I said, it's normally either like special IoT devices or users plug in CPUs without 464 flat support, except for places when we have gym. Utilization as a result. What we observed is that utilization on pilot sites for DHCP before pool dropped between like 5-8 times, which actually correlates very well with those like average 15% of users staying, 5% falling back to dedicated fallback SSID, 10% using 2.4 SSID. So yeah, 15% of users still utilizing our V4 address space. So as a result, we were able to, being conservative, we basically reclaimed 75% of our address space initially allocated for guests. And for wired, yeah, we reclaimed a lot because, as I said, we initially had to provision enough address space for every single device in the network to wired device to fall back to wired guests. And now we don't need this. We just provide /27 per site for those special use cases, and that's it. Well, what doesn't work? Actually, I'm supposed to publish, I have a small website I'm supporting to publish the full list of external stuff, which does not work, but I have not done it yet. Those, I have maybe about 25 open bugs currently in my like known issues tracking list. Those top 5, and actually I think there is a big gap between top 5 and the rest of applications in terms of number of complaints I received. Obviously, exercise equipment. Be careful if you have network connected gym devices. They do need IPv4. Secondly, second biggest one, everyone who uses Spotify, please go and click on this link and upvote the request. Because Spotify application on laptops, it works if you're using in the browser mode, but application itself doesn't really work very well last time I checked on V6 only. And the way Spotify fixes the issue is that you open a issue there and they wait for community to come and upvote it to demonstrate it's important. Yeah, obviously third-party VPN system. And actually most of them do not work just because the remote side did not enable IPv6 on the VPN concentrators. And actually one of those companies our people connect to actually fixed it for us. And some of them are now considering fixing it. So normally there is no like protocol issue, it just does your VPN vendor supports it. Yeah, I got a lot of complaints about StarCraft not working. And actually I think Steam does not let you sign in on IPv6 only as well. So online gaming is a big thing, but we did not consider it to be a deal breaker and business critical, sorry. Also, macOS Internet Recovery Image, anyone from Apple around? I actually heard that this thing is going away soon, but yeah, I think devices will be using Internet Recovery Image will be around for a while. So this wasn't a big issue for us because it's provisioning thing. You can use dual stack SSID for provisioning and then go back to V6 only primary one, but still it's one of these provisioning things which does require V4. So,
Jen, we have another question in the chat room.
Yeah.
Why do you think IoT is the main IPv4 use case? IoT seems like it would need more addresses, and so would really want to use V6.
It was my impression as well, but I'm saying about what I observed, right? All those, maybe I shouldn't be saying IoT, but actually, yeah, sensors were a problem. So basically, all this like a embedded system, everything which is not laptop but has a kind of small network interface, but computing is not its primary thing, was having issues. We had building management system, like some smart bulbs, and all this like stuff. At least things we were a user was not really supported V6. And every time you talk to those people, like when you put IPv6 as a requirement and RFP, they're like, IPv6? Oh my God, why? Do you really have IPv6 enabled? And I'm like, yeah, we have IPv4 turned off. So I was surprised as well. I don't know why it is like that. I guess because of the usual chicken and egg problem. Everyone was connecting those things to IPv4 networks, so they happily use IPv4. So this needs to change, right? We need to put this as an RFP. We don't go and replace those devices because they don't have IPv6, but the goal is at least to start getting new devices which have IPv6 support, right? So yeah, I don't know why they don't have V6 support. It's just a reality, at least what we observed. So dedicated fallback network. We actually initially hoped that maybe we do not need dedicated fallback mechanism for Wi-Fi, and we can use 2.4 SSID as a fallback. But we realized now it might not be desirable. So what we ended up doing for the wired network, how it works now post-pilot, users could not do just self-sign in and request IPv4. They need to file a request. That request will be reviewed and usually approved, but it's a temporary exception. We tell users, we're giving you IPv4, but it's for 18 months. We can extend this, but we need to see an exit strategy. We need to see that you talk to a vendor and request IPv6 at least in the next release or next iteration of the hardware. Because otherwise, if you just give users IPv4, they will never start fixing anything. And yeah, upon that request is filled, yeah, we just moved port to dedicated dual stack VLAN. For Wi-Fi, we ended up having a dedicated dual stack SSID, but I do not think it's the best strategy, and I will be back to this why in a few slides. Showstoppers. Well, surprisingly, no, especially if you do give users a mechanism for fallback, right? Again, it does depend on your network environment, on type of devices you have. Your experience may vary. Mobile devices mostly just work, right? If you have mobile phones, good. If you have laptops with millions of other applications, it might be a completely different story, actually. So yeah, you need to try it. It worked very well for us, surprisingly. Or impact on support team, very low, actually, almost none. But we did something to make it happen. The key thing is to plan ahead, right? You need to work with them in advance to make sure they're not getting overloaded. First of all, we were letting users know about the change. We were telling them, okay, guys, you might not understand what it is, but it's coming. And we also, in that notification, we told them what to do if something does not work, just to minimize impact on support team. Also, we worked with our first line support. We gave them troubleshooting flow charts, simple thing just to confirm if this issue is actually related to IPv6 only migration or is just something else. And we maintaining known issues page. So both users and tech support could go there, check first, oh, maybe it's something we already know about, here is your workaround, go and use dual stack. If it's something new, please report it so we can work on it. So yeah, this was actually much better than I even expected. So lessons learned, what we learned from this. First of all, please tell your tech support, never tell users disable IPv6 as a workaround. Because it happened before and users happily read the instructions, oh, if something doesn't work, just turn off IPv4. They do this, they go away, and they never turn it back, right? So one day you turn off IPv4, and that device just follows the network because there is no way to find those devices and re-enable it. This is a very bad idea, right? You can do it for troubleshooting, but the last step should be please re-enable back. Never, because we did find a number of laptops when users just had IPv6 disabled and then they could not connect. So I keep saying that what we were getting before was not actually an IPv6 operational experience, sorry. We were operating dual stack. You really start getting operating IPv6 network when there is no IPv4 to hide all those issues from you. Because actually this presentation should have another 30 slides with all these various funny bugs we discovered, but then I guess I would need another 3 hours to tell you all those war stories, so maybe next time. But obviously, we found a lot of interesting network issues. Some of them were network vendor bugs, obviously. By the way, you know that, for example, some platforms are happily sending VRP packets from duplicated IPv6 address. As a result, they happily stay in VRP master despite not being able to send or receive any V6 packet. So anyway, also if we found interesting corner cases in the protocol itself, right? So in Dcache init draft just cleared working group last call. So it was one of the examples of the issue which has been there all the time, but nobody noticed until we turned off V4. And obviously, yeah, all these vendor bugs and broken V6 things became much more visible when we turned off V4. Also, there are process issues. This is IPv4 first operations mindset. Operations people normally, when they verify the connectivity, what they do? They ping over V4. Normally, they don't even bother to verify V6 because V4 is working, that's fine, right? This is going away because now they immediately see impact if V6 doesn't work. Also, we find out that there are a lot of designs which might claim IPv6 support, but they might have some underlying IPv4 dependencies nobody even been considering. And again, those kind of issues become very visible. So it was actually a good thing, but you need to keep it in mind that KPI both mask all that stuff. You might not even expect it. So, early adopters. It was a very good idea to start with opt-in because as a result, you get technical people who care and try to and are willing to try IPv6 only and report the issues, which would allow you to find the maximum number of issues with minimal user impact without affecting non-technical people who do not care. So IPv6 only support requirements. We also found that we have not been clear enough in our requirements for equipment and software, because sometimes you just tell, I need your system to support IPv6, and the vendor would read that I can assign the IPv6 address on the interface, maybe even just in local one, and that's fine. No, you need to explicitly tell, I want RDNSS, because without RDNSS, you wouldn't be able to get DNS 6.4, right? You need management over V6. You need 464 swap for CPs and so on. So, the main point, why I believe that dedicated SSID or dedicated network is not a good idea. First of all, we found a lot of issues with naming. If our primary SSID called guest, how shall you name this fallback SSID? It should be less attractive that people do not connect there by default, but still attractive enough that people would connect it if primary one doesn't work. Naming is hard. So also, quite often, people do not even care what SSID they connected to. They just connect to something and it works. Also, device might start switching between different SSIDs, and you don't know again which one would be preferred. And once the device remembers SSID, there is no way back, right? So users would use it maybe accidentally. So we actually consider stop broadcasting the fallback SSID, which would still let users who need it ability to use it, but they would not be connected by default. And the third issue is, especially for wired network, it does not scale. we cannot double number of VLANs for dual stack and V6 only devices. So what I really want is to have V6 only and IPv4 enabled device coexist on the same network segment. And hence DHCP draft, which is currently, I think, with ISG, suggesting the mechanism to for host and DHCP server to talk to each other, and DHCP before would work only for devices who really need it, and devices who are capable of being V6 only would just stay V6 only on the same network segment. So the current status of all of this, I wish I could say all offices now have V6 only guest network, but I think we're still a couple of weeks away from this. But so anytime you
Sorry.
visit our office.
Thank you so much.
I mean, you can stay here, but it'll probably be irritating.
No, it's all good.
Yeah, so we're basically almost done with migrating all our offices into V6 only guest network. So I think I might be slightly over time, but I hope we might have some time for questions. No question. Shall I stop sharing? Yep. How can I do this? Oh, good. Okay, so
This is Warren. I did do a plus Q, but I guess I'll just jump in. Doug Montgomery had earlier asked, would this working group consider hosting a living document of applications/systems that have identified issues operating in a V6 only environment? A community effort here would be useful. So basically, you know, do we want a wiki of things that work and don't?
I actually started turning up a wiki on my side for this. Unfortunately, I was hoping I could share a link, but I just haven't done it yet. Yeah, there are two kinds of things. Some things just do not work. Some things have workarounds. For example, Tor browser, as far as I know, there is a workaround you need to explicitly configure, but it works. So yeah, I think we need to document it there. I'm not sure if it's going to be living document or not.
For the unshare?
Yeah, I'm trying to click on stop sharing, and it does not happening. I'm how can I stop sharing?
I think there's something at the very top, kind of a tab that says sharing.
Yes, and I click on it, and okay, I think what I can do, I can just, what's going to happen if I do this? Okay, let me, okay, does not, okay, you know what? If I'm done, I might just do this. I'll be back.
Okay. Okay, thank you to Jen and Absentia. And Jordy, I think you're up next. Am I on mute? No, I'm not.
Oh, okay, I guess I was on mute. Chong Fen, could you share your slides and start?
Okay. Hello. Can you see the slides?
We can now.
Can you see the slides?
Yes, we can see the slides.
Okay. Hello, everyone. I'm very pleased and happy to have this opportunity to share something about IPv6 development and the current status of China Telecom and China. Thank you for giving me this opportunity. First, about the IPv6 status of China Telecom. I also wrote a draft about the IPv6 development of China Telecom to support this presentation. I hope you can review it if you are interested in it. First, about the introduction of China Telecom. China Telecom is one of the three major operators in China, and the other two is China Unicom and China Mobile. China Telecom is an integrated information service provider. It provides voice, wireline, mobile broadband, video, LISNine, and VPN, cloud, SCT service, etc. And the service coverage area includes all the province regions of China, and also provides service in some foreign regions, for example, North America, Europe, and Australia, etc. And right now, the quality of users is as follows. There are about 163 million household users, and the number of mobile users is about 308 million, which including 200 LTE 4G mobile users. The architecture of the IP infrastructure of China Telecom. The IP network of China Telecom is a multiple AS system, and it includes backbones, metro network, and 4G, 5G mobile calls, and IDC clouds. There are two backbones, ChinaNet and SIM2. Both of them are nationwide backbone network. ChinaNet is a native IP. Right now, it supports IPv4 and IPv6 dual stack network. ChinaNet mainly focuses on to provide services for provide service such as mobile internet, etc. Different from ChinaNet, SIM2 is a MPLS-based network. It is also IPv4 and IPv6 dual stack. It mainly focuses on enterprise users to provide VPN service and some quality-sensitive service such as VoIP and high-speed interconnection among IDCs, and also metro network and IP RAN, 4G, 5G mobile call, and the IDCs are connected to the two backbones. So IPv6 work of China Telecom can trace back to 2002 by testing IPv6 in Hunan province. And we successfully deployed IPv6 in ADSL network then. But now ADSL has nearly vanished in China and replaced by optical access. And then we joined the Xinjiang project of China in 2003. Then in 2012, and the field trial in metro network was conducted to evaluate the different transition mechanisms, which is nearly in parallel with the standardization process in IETF. In In 2015, IPv6 was deployed successfully in 4G mobile networks of 2 provinces, Hunan and Jiangsu province, thanks to the well support IPv6 in EPC and the mobile phones. Then when the IPv6 action plan was launched in November 2017, a comprehensive IPv6 deployment started in all networks, for example, metro, mobile, backbones, IDC, clouds, etc. So metro network was the primary scenario to implement transition. I remember that in 2012, a wide variety of transition mechanisms was evaluated in the field trial. And it took us a lot of time to compare and evaluate DisNight, DualStack, DisNight, IVI, and MapT, MapE, etc. And in order to support multiple transition mechanisms, the supporting system was also upgraded to adapt to different transition mechanisms based on the capability of the CPE and the availability of the resources in the network. However, due to the fact that most transition mechanisms do not gain support in CPE, so DualStack was later adopted as the main approach for metro networks. Since 2017, all the BNGs in 218 metro networks have been upgraded to provide IPv6 access to household enterprise users in 31 provinces. Right now, about 44% of the household users are IPv6 capable, in which 24.6 million users are active, and the rate is about 51%. Different from metro network, and the IPv6 deployment in mobile network is more straightforward. This work began in LTE in 2015, and we only switch on the IPv6 capability in the user plans of EPCs, and then each user was allocated with 1/64 prefix of IPv6 and IPv4 address simultaneously. And it should be noted that EPC equipment, EPC of China Telecom is constructed on a provincial basis, which means that there are 31 EPC networks in China Telecom. So for a given province, when IPv6 capability is enabled, every user from each province can get IPv6 address, and it does not support IPv6. Since IPv6 has good support in mobile phone of LTE, so IPv6 penetration rate of mobile is higher than that of well-known users. Right now, there are about 230.7 million online users, and the penetration rate is about 80%, of which there is about 160 million active users. So the penetration rate is about 60%. Data center is also an important place to provide broadband service for enterprise users. So right now, about 450 IDCs are IPv6 enabled, which means that all the IDCs are IPv6 enabled. So this is a basic foundation for IPv6 services. In addition, because China Telecom also provides cloud-based computing service to users, so we upgrade the computing platform to support IPv6. And right now, there are more than 50 IPv6 enabled cloud products, such as ECS, GPU, and load balance, VPC, etc. So with these capabilities, cloud users can provide IPv6 services. This is about the IPv6 traffic. And right now, the IPv6 traffic increased rapidly. From the last figure, we can see that the traffic in the well-known network has reached 1 terabits per second. And the traffic in mobile network is about 500 gigabits per second. So which means that the traffic in a wired network is much higher than that in mobile network. But the traffic rate in wired network is only about 2%, and the traffic rate in mobile network is higher than that in wired network. It's about 10%, and the traffic in mobile network increased rapidly. We are very concerned about IPv6 usage in service system. Here's give some data about IPv support in Alibaba's apps. From here, we can say that many popular apps of Alibaba are supporting IPv6 in China. For example, regarding the IPv6 traffic ratio, Youku, which is one of the largest video service platform, the IPv6 traffic ratio has reached 92%, which means that only 80% of the video is carried over IPv4. And the second apps, which is about Ele.me, which is about 65% the traffic ratio. And the Golden Map, which is very popular in China for navigation, the traffic ratio is IPv6 traffic ratio is 50%. Alipay, which is very popular for e-payment, is a very popular e-payment app in China, and the IPv6 monthly active user ratio is 90%, which means that 90% in China have used Alipay by IPv6 within 1 month, or at least once in China. And Taobao and Tianmao, which is also very popular in China, also has not begun to use IPv6. So right now, Alibaba Group server has more than 500 million monthly active users around the world. And China Telecom also tests the apps IPv6 support by other apps. From here, we can say that IPv6 has been widely utilized in some apps. The first one is Qiddian mobile reading. The IPv6 ratio is 89%. And Dianping, Dadong Dianping is a very popular apps to order food, which is about 85% of the IPv6 ratio. And Xinjiang Weaver is very popular in China, and the ratio of IPv6 traffic is 60%. And WeChat, which may be the most popular social apps in the world, and the IP ratio is 40%. This data was collected from 4G network of Hubei province. So although we have made progress.
So let me get a word in edgewise here. We have a question in the chat. I think it's actually from 2 slides back. You mentioned 90%. Is that 90% of IPv6 enabled users or provinces, or is it of all users?
90%. All the mobile users, 90%.
Okay, thank you.
Okay. So we still face some challenges. The major challenge is how to further improve IPv6 usage and make IPv6 ecosystem much better. That's very important. For example, the first one is the no IPv6 support in home router CPE, because a portion of home CPE router in China do not support IPv6, which influence the penetration rate and IPv6 traffic. And users can buy the CPE router from the market freely and install it at home without any permit from operators. However, there's some good news that after realizing this problem, the IPv6 community has jointly pushed the vendors of CPE router to improve IPv6 support in their products. The second challenge is the slow transition on content and service side. This may be an older topic. I think that one reason for the content service provider is that the service layer transition depends on the user's on the IPv6 capability of a low layer networks such as CDNs and IDCs, and they are required to support IPv6 in advance. The second reason maybe is content provider are very concerned about the end-to-end performance of the IP networks, especially in China, in such a large country. So even though IPv6 has been implemented in the products, they are still very cautious to switch from IPv4 to IPv6, the client software. For example, WeChat. I know that WeChat has supported IPv6, but they increase the scope of this increase the scope of IPv6 users step by step based on their test. However, we are still IPv6 has been utilized in other new scenarios with development new digital era. For example, IPv6 can be used in IoT. I think this is a very important scenario. 5G, V2X, and the network cloud convergence, etc. And also, as I have mentioned in IETF 106 meetings in Singapore, we have conducted the SRv6 field trial in several scenarios. For example, metro networks, we design new metro network architecture with SRv6, and the mobile transport networks and anti-DDoS system, etc. And this work is going on. And the third one is about the network migration in the future. Right now, we have a large-scale dual-stack network system. We need to consider how to move to IPv6 only, as Jane has mentioned. Yeah, I think that IPv6 only will be very important in the future. So we need to, in order to reduce the kickbacks and the OPEX and make the network more concise and secure. So that's a very important aspect of IPv6. This is about IPv6 of China Telecom. Then the second one is IPv6 status of China. Firstly, I want to talk about the IPv6 action plan of China. In November 2017, the CPC General Office and the State General Office of China jointly issued the large-scale IPv6 deployment action plan. Here, CPC means Chinese Communist Party. This is a very important event for the IPv6 development in China. So with this policy, the government required all the operators and all the major content service providers, such as Alibaba and Tencent, and all the major content and cloud providers are required to support and enable IPv6 in their network or service system. So this work has been lasting for more than 2 years. And the action plan is composed of 3 steps. The first step is that by the end of 2018, the active user will reach 200 million and the penetration rate will be about 20%. The second phase, by the end of 2020, and the active user will reach 500 million and IPv6 penetration rate will about reach 50%. And by the end of 2020, there will be no private address usage in new network. And in the third step, by the end of 2025, China will set up the largest IPv6 infrastructure in terms of IPv6 user quality and IPv6 traffic. So this is a large goal. It is very challenging. In order to support IPv6 deployment in China, and CAICT, which means Chinese Academy of Information and Communication Technology, CAICT developed a national IPv6 development monitoring platform. which is also a distributed system. And with this platform, we can monitor network performance from end-to-end performance and monitor the IPv6 capability of the website, major website, including some website of the government and not enterprise, monitor the apps, and also test the UE and CPE equipment. And also with this system can display the latest information about the network, information about IPv6 development. For example, the network transition, user quantities, traffic volume, CD cloud, apps, terminal, etc. This work is still, this has run for more than 1 year. It is still being updated based on new requirements. So how does this platform measure IPv6? In order to get the IPv6 users number, the system periodically sample user access logs from China's top 30 apps. Of course, users' privacy are protected in this process. And user traffic data is directly obtained from the network or carrier network operators OEM system or system. So which means that all the data are collected from inside of the network, not from outside. So IPv6 performance is measured through the agents deployed in the network, and also there's some software from user side by issue one-way and round-trip ping, TCP, HTTP, and streaming access to measure the network performance and end-to-end performance. And also, we developed some kind of cron or special apps which can be installed to for Android to detect the IPv6 reachability detection website apps. IPv6 support detection for deep links and the rich IPv6 traffic. Of course, because there's a lab which tests the mobile UE and the CPEs to verify IPv6 support and whether they can get IPv6 address or the performance. Here is about the number of users by June 2020. The quantity of IPv6 capable users has reached 1.33 billion, and there are about 1.15 billion IPv4 4G users, and the penetration rate is 90%. This is a penetration in mobile network. And of course, we are concerned about active IPv6 user. The active here means that the user has at least once visit of the service by IPv6, at least once within 1 month. So right now, the total number of the active IP users is about 370.8 million, with a penetration rate of 37.2%. Because right now the Chinese in China, the internet population is 554 millions. From this graph, you can see that from this figure, we can see that the quality of apps increase gradually. And this is about the traffic. By June 2020. Right now, the in metro network, the inbound traffic from server side to user, the inbound traffic is about 4.45 terabits per second, and increased by 165% than January 2020. And in LTE mobile network, the inbound traffic is 4.16 terabits, and increased by 151% in January 2020. And the traffic between operators about 190.87 gigabits, and the international traffic is 72, which is much lower than its domestic traffic. So from the figure, we can see that the traffic increased gradually during the last half year. But right now, the overall ratio of IPv6 traffic is still less than 10%. So this is still low. So there's still more space for IPv6 development. So,
okay, Chongfen,
okay.
Davey Song has a question in the chat room. He wants clarification on the IPv6 MAU ration apps of Alibaba.
Okay.
Davey, maybe you want to enable yourself to speak and get into that question.
David, what's your question?
He writes in the chat, I would like to ask the floor for clarification on the IPv6 MAU ration apps of Alibaba.
Sorry. This data was provided by Alibaba. So what's your problem, David? What's your question? Sorry. I cannot see the question. Can someone tell me the question?
Well, what he wrote is he wants clarification on the IPv6 MAU ration apps of Alibaba. So and I'm sure he means ratio, not ration. He's probably being spell checked. What does the acronym MAU stand for?
MAU stands for monthly active users.
Monthly active users.
Yeah. Because we are concerned, because we think that active user number should deserve more attention than the number of users who only be allocated IPv6 address.
Can you hear me? This is David. Okay. I just muted myself. Sorry. I just want to make a clarification that the IPv6 MAU ratio is not as same as the traffic ratio, because in the traffic ratio, the part of IPv6 plus the IPv4 equals 1, right? Equals to 100%. But the MAU ratio is not exactly the same, because if you count the IPv6 users in 1 month active for once, they may active many times in the month in IPv4 appears in IPv4 networks. So the ratio of IPv6 is plus IPv4 don't equals to 100%. For example, for the Alipay, we count the 90% of the IPv6 MAU, but actually the IPv4 users may the 100%. MAU may be the 100%. Yeah, yes. I just want to make that clarification. Yeah.
Okay, thank you.
Okay, I interrupted you, Chongfen. Please continue.
Okay. Okay, thank you. Fred asked me to make some comparison of the measurement with APNIC and ACMAN. This is a measurement from APNIC. From here, we can see that 18% of the users are IPv6 capable in China, only 8%, which is less than that of the measurements in China. This is the measurement of from ACMAN, which shows the ratio of IPv6 enabled web browsers, which shows that 15% of the web browsers are IPv6 capable. So I will, yes, there's some difference between measurements. So I give a short summary. Due to joint efforts, IPv6 had gained wide deployment in China and it became a universal capability in the IP infrastructure. Further improving the traffic by the transition of content service system and improve the IPv6 web will be essential for building a better VCU system. That's a major challenge. And along with development, new digital area IPv6 will be used in scenarios such as 5G, OT, network cloud convergence, and then the 2x. So in combination with SRv6, IPv6 only or IPv6-centric will be the path of future migration. So I think it is important for us to consider designing IPv6 network architecture in the future, which can be helpful for large-scale network transition. I'm done. Thank you.
Okay. Questions? Paolo, you want to ask your question, Vox?
Okay, hello, can you? Yes, my question is about IPv6 versus IPv4 performance. If you have ever test or measurement just to see whether one is faster than the other in terms of latency. Thanks.
Right now, we have done some measurements, and in most province of China, the performance similar to IPv4, but in some province, the IPv6 performance is lower than IPv4. So we are concerned about this by the network equipment and optimize the routing, etc., which is essential for IPv6 in development in China Telecom. I'm not sure what question.
Sure, thanks. Many thanks.
And I also know the apps, for example, Alibaba and some apps of Alibaba and Tencent, they have also done some measurement of the network performance, IPv6 performance, and make some comparison between and IPv6. And so I think this work will be also helpful to improve the IPv6 in the future. About the difference of measurement between China and APNIC. Actually, this I have talked this with Chief Houston for a long time about this issue, and he told me that the measurement of APNIC is based on as some kind of as-based measurement. So this is this is a. I think that the difference mainly due to the different methodology, as Fred has mentioned. First, the measurement APNIC is done from outside of the network, and it is an as-based measurement. So, as-based measurement approach suffers from measurement bias, which means that the as placement is in proportion to users population. So, which means that need some kind of compensation mechanisms of the population of the user data, but as far as I know, they cannot do this kind of data, so they cannot do this kind of compensation. And another issue that the measurements rely on the web browser. But today, most users mainly use apps instead of browser to access service. So there is possibilities the measurement result is not consistent with the reality. The measurement of channel based on the collection of data sample from inside the network or service platform. The result may be more accurate. However, we still think that the measurement APNIC is a great system. They have done good job. So we respect the measurement APNIC which are very helpful for us to analyze the network. And certainly, I don't think the difference is related to some kind of filtering. I have done lots of tests. My colleagues distribute in different province, job, and it seems that most of the measurement communication were normal. There's no sign of that the measurement data has been filtered or during the transition, during the Thank you. Other questions?
Yeah, I have one. On many of your slides, we have seen that your number of users, IPv6 users, is already very impressive. It's very high number, 60%, 80%, very good number. But for traffic, it's still 15%, 10%, different slide, different percentage, depends on fixed broadband, mobile broadband. But anyway, the percentage of traffic is much smaller than percentage of user. Why?
As I have mentioned, there are many apps and in China, many other big apps, large-scale apps in China. They have been not IPv6 enabled. Maybe they have only provide IPv6 in a small area, not in the whole channel. So we need to push them to enable IPv6 in their service platform to support IPv6. To enable IPv6 in their client software to support to be IPv6 capable. I think that's a major reason.
Okay, thanks. It's application problem. Okay.
Okay, thank you. We can see that the traffic increased rapidly. I think there's space for the traffic increase in the near future. Thank you. Other questions? Any other questions?
Yeah, who was it that asked that question? Warren needs that.
Sorry?
The question that you just answered that. Oh, it's Edward. Okay.
Yeah, last one. Yeah, last one from me. Yeah.
Okay, great. So, are there any further questions? Failing that.
Okay, go ahead, please.
John Fenn, go ahead.
Okay, if you have any more questions, you can ask me by email. Okay, or talk with me offline.
Okay, great. Thank you.
Okay. Thank
you. Now Jordy has asked for a few minutes to talk about the 464XLET stuff. Jordy, you want to, Chongfen, I need for you to stop sharing. Jordy, do you want to get in here?
Yeah, let me start sharing when I can. I don't see the start sharing thing. Where is it? I have used it many times, but I don't see it now.
Well, I think Chongfen needs to stop sharing first.
Okay.
Okay, great. So Jordy, you should be able to share now.
I am trying, but I don't see the sharing thing. It's been the three dots or where? I did many times, but I cannot find it right now.
I think it's up at the top of the screen.
Mac, it's on the bottom next to the camera icon between the camera and the second person.
Yes, I see it now. Sorry. I am confused with so many different conferencing applications. I think you should be able to see it now.
Yes.
Yeah, okay. So quick remember about this draft. We are right now in version 2, which has been published about 5 days ago, I think. The basic problem statement is that when we are using NAT46, and that happens both in MAPT and 464XLAT, if you have IPv4 only devices, for example, smart TVs or set-top boxes, their connections to the CDNs are going to be naturally terminated in IPv4, which means that you are forcing two translations. One at the CPE from IPv4 to IPv6, and again, another translation at the NAT64. That means, of course, a lot of extra utilization of the NAT64, which we believe is useless and in many cases maybe a showstopper for deploying IPv6 only solutions. There is an equivalent situation when you have IPv4 only CGNs, but in that case, the CDNs are typically accepting via direct biddings, like communities or other ways, private addresses from the ISP network. So in that case, this is solved. So just to show how it happens, let's think this is a typical 464XLAT deployment where you have here the user dual stack LANs. You have the CPE, which has the NAT46. Then we have an IPv6 only access to the ISP. We have the NAT64 that allows accessing IPv4 devices. You have also, of course, the DNS or DNS64 or both. And then you have other networks which are IPv6 enabled, right? So if the devices inside the user LANs are IPv6 capable, we will have this green line end-to-end IPv6 to the dual stack CDNs. Okay, so it's clear that this is very optimized. But if you have any IPv4 only smart TV, the traffic flow in this case will be IPv4 to the CPE, translated in the CPE, translated again in the NAT64, and then we will reach the IPv4 end of the CDNs, even if the CDNs are dual stack, okay? So what we try to avoid is, if the CDNs are already dual stack, why we need to translate here again, if we have already here IPv6 translation, okay? So this will be the optimal situation. We have still the IPv4 only device like a smart TV or set-top box, which for whatever reason cannot be updated or it's too old or whatever. We do the translation in the CP exactly the same as what we do today with 464XLAT and MAPT, but we want to be able to keep that translation instead of going through the NAT64 to reach the IPv6 side of the dual stack CDN. That's the goal, that's the optimization, okay? Now, we have described in the document 3 basic approaches. The first one is trying to do the same as what is done in CGNs with IPv4. But in the case of IPv6, that will mean that the interfaces of the CDNs, they configure the same prefix, in this case, the well-known prefix of the NAT64 that the ISP is using, okay? So most of the CDNs, when we talked to them, they said, we cannot do that. Some they may be able to do, but most of them not, okay? So this seems like a non-possible approach, at least not covering most of the big CDNs. The approach 2 is because the 464XLAT and MAPT require that the CP has also a DNS proxy, we could do a static mapping, what is called explicit address mapping table for the A records with the quad A records in the CP. That will mean that the CDN don't need to change anything. And what we are trying to do is to make this happen magically. And of course, the goal is to avoid any breakage in any other kind of service or application or whatever. And the approach, let me jump to approach 3. The approach 3 is doing the same, but creating this explicit explicit address mapping table by means of a manual configuration from the ISP, okay? But this again will need a lot of coordination with the CDNs, and it seems not so easy as well as like the first approach I mentioned. So what happened in the last few days is that the document passed the last call, but it seems that many people missed that. So Jen was assigned as cheffer for the document. She provided a lot of very useful inputs. At the beginning, most of them were basically many editorial comments or clarifications in the text. This is the actual version that we have, version 2. And after that, there were some additional discussion in the mailing list. There are further comments from Jen, from Eric, from Basilenko, and also from Eric Klein. And what I am missing, because those comments come yesterday and before yesterday, and I didn't have enough time to tackle that in a new version for today. But what I am going to do is, I guess it don't make sense to keep the document in last call. I guess it is clear that it needs to go into another round of discussion, and then if necessary, we can call again for a new last call. But there are some points like ensuring that no breakage is generated, security issues regarding DNS and others. There are comments, I think, from Eric Nigren about clients catching and TTLs that I need to review, and some other comments. I didn't want to make a full list of them, but the motivation of this presentation, of course, is for other people to please read the document, provide inputs. If you have a better idea about how to optimize this, let us know. And let's keep discussing it for a new version. I think in the next 2-3 days I could have a new version with all the comments that I have received. But if I keep going other inputs, I will wait for all of them to come before publishing a new version. And I think that's it for this part of the document. And as part of this discussion, we have another related discussion that actually was among Jen, the chairs, and myself, which is we know that clearly 464XLAT is the transition mechanism that have more subscribers, okay? However, it's the only transition mechanism which is not in the standards track. It's an informational document. So I was thinking that if we pass the last call of the optimization, we can actually consider going into a standards track. But because we are delaying this until we have a better solution or a better wording for all the document and so on, I still think that a parallel activity or a parallel work could be getting 464XLAT moving to a standard. I think some people may agree with this. I think Jen told me, yes, we should do that. It's clear. Other people in the other round of discussion that we have about this tell me the same. But I have also the question, the open question about if this is something that could be done in V6OPS, because I believe, if I recall correctly, that was done in Behave, but Behave no longer exists, etc., etc. So open discussion on that, and also inputs to the optimization, please. Thank you.
Okay, related to this topic, 464 XLAT was actually put forward as a as an operational way to use stateless and stateful translation. So the document was produced in V6OPS as an operational document, and it's informational because V6OPS isn't allowed to produce standards. So I will have to talk to my chair, or to my AD, and basically get his okay to take it to standard.
Fred, I think the main question is if we agree that it don't make sense having the most used mechanism not being a standard. That's the first question that we need to make ourselves, right? And then find a way to do that.
Okay, well, that's a question I'll ask on the list. But right now, does anybody object to what Jordi is proposing here? Hearing no objections, I'll take it to the list and we'll see what we get. But I would expect that, yes, we can ask the IESG to simply change the status of 6877.
I don't think anything needs to be modified, but I am happy to talk with the original authors and get the work done with them if we need to update anything else.
Okay. We'll probably want to go through some variation on a working group last call with that to collect comments. You know, if people want to change 6877 in any way, that would be the way to collect that. Now, if you look in the chat room, there's also, Warren is of the opinion that it should be, that this document should be reviewed by DNSOP. I believe they're meeting next week. So I'll drop a note to the chairs and copy you and ask for a slot for you to make a presentation talking about your proposal.
Yeah, okay.
Okay, so now also, if you look in the chat room, I have asked for 2 people to review this and post their reviews to the list. The reason being that Jen, as document shepherd, is of the opinion that it hasn't had sufficient review. So can I get 2 people to review it? Edward, you said in the chat room that you would be willing to review it? Okay, fine. So please review the internet draft and post your review to V6OPS. Can I get one more reviewer?
There is a couple of extensive emails, one from Eric Nigeren, and the other one I think is, well, Jen has another one as well, which is basically about DNS spoofing, I believe, and other security issues. And there is also another one from Eric Klein. So I will, of course, respond in the list to all those inputs. Just didn't have time in the last couple of days.
Okay.
I say that to avoid repeating over the same topic. Right?
Yeah, okay, got it, that's fine. Okay, well, I don't hear another volunteer to be a reviewer, but Jen, would those emails respond to the question that you were asking me?
Fred, yeah, I just would like to point out, so I think the most current open issues with the document is security considerations, because people have pointed out a number of very interesting attack scenarios, right? And the second issue is how fragile the solution is, right? So it would be nice if we could get more people reviewing it. So I think two should be fine, but I guess there are some open issues already on the list which haven't been addressed in 02. So I'm just curious, so are we going to do another round of last call for this? Like, what's our timeline? Do we want to do official last call, or?
I guess we need to have a stable version first, right? And then we can think in the last call. But I think unless there are a lot of new inputs, I think I can get a new version around next week maximum. But it depends if we have more additional inputs, and it depends also if I am able to find a solution to the possible security problems, because maybe I don't find a solution, right? So I don't know at this time.
Yes, I think you cannot post anything until 25th anyway, because the data tracker is locked. And again, I think I posted it on the mailing list today. I think we might still consider if your first proposal, I mean section 5.1, might be actually the optimal one, because it's less fragile. Yes, it does require operators, CDN operators, to do something, but if they already allow you to bypass CGN, it's not much work for them. It's basically the same.
Jan, I already thought on that. I was thinking this morning on the paper during 2 hours this morning on this. And there is a big difference. In the case of IPv4 CGN, the operators don't need to have different addresses for the services in their interfaces, okay? But in IPv6, they will need to add new DNS records, addresses to the interfaces to match the well-known prefix from the operator. So there is it's a small, but it's a lot of additional work. It can be probably automated, but CDN providers told me, we don't want to do this. If they change their mind, I am really happy.
Okay.
Okay, so this WebEx session is scheduled to end in about a minute and a half. So, question, does anybody else have anything to bring up in the very short remaining time?
Let's keep working in the list then.
Yeah, let's take this to the list. And Jen, you can expect probably a working group last call sometime in August, but we'll need to get an updated draft and some comments on it first.
Thanks for doing this, yeah.
Okay, well, and thank you to all the people that attended. I think at our peak we were around 70 people this morning. Right now we have 41. So I'll be sending out the link to the recording, and you can look for that on the list. So we're done. Thank you.
Thank you very much.
Take care.
Bye.
Cheers.